Welcome to Emilak Online Tutorial. Before us is this question in trigonometry, and it says an angle of elevation of the top point P of the vertical tower PQ of height H from a point A on the ground is 45 degrees, and from a point B the angle of elevation is 60, where B is a point at a distance D from the point A measured along the line AQ, which makes an angle 30 with AQ. Now prove that D equals H into the square root of 3 minus 1. Now first of all, let us draw the diagram. This is the point and the ground. Okay, now this is our A. Alright, okay, so now this is our point P and this is our Q. Now here we have 45 degrees, okay, and we are told that from a point B the angle of elevation is 60, where B is a point at a distance D from A. So let's assume this is our point B from A, and that angle of elevation so here you have what, 60 degrees. And take note, we are told that it actually makes an angle of 30 with AB. So from here this will be 30 degrees, okay, and we are told that here from here to here is the height H. We are told to find, let me paint this, and we are told to find, or rather to prove, that D equals H into 3 the square root of 3 minus 1. Now first of all, let us fill these lines first. Okay, now take note that this is 90 degrees, and because this is an horizontal line, here we have what, 90 degrees. All right, so now if you take a look at this 90 degrees, now it implies that this is a triangle, and the sum of angle in a triangle equals to 180. Now here we have 60, here we have 90, and to complete 180 here, it implies that this will give us what, 30 degrees. Okay, and this is because 180 minus the sum of this angle, that will be 150, which will give us what, 30 degrees, and that's how we got 30 degrees here. Okay, and from here now it implies, if from here to here is 30 and from here to here is 45, it implies here that the remaining part here will give us 15 degrees. Okay, now if here is 15 degrees, okay, now if you are to make here 45 and here is 90, now if you are to get this triangle APQ, you see that this is 45, this is 90, and for us to get this part here, we have 180 minus the sum of 45 and 90, and that will be 135 degrees. Okay, and 180 minus 135 will give us 45 degrees. Now if the whole of this place is 45 degrees and here is 30 degrees, it means that this part will give us what, 15 degrees. All right, I guess we are getting out we are getting out something here. So now if here is 15 and here is 15, by the triangular law that says the total sum of angle in the triangle is 180, so we can imply that this 180 again minus, now the sum of 15 plus 15, that will be what, 30, which will give us what, 150. So here is 150. Okay, now still considering this triangle, angle APQ, here is h, here is 45, and we don't know this AB here. Now let us find AB here. Now using this angle here, we have the opposite. As per the right angle triangle, here is opposite, here is adjacent, here is opposite, and here is hypotenuse. Alright, and that will be, just use SOHCAHTOA. And by using SOHCAHTOA, you can see the relationship here within the angle and the sizes I've measured now is tan. So here we have tan 45 equals to opposite, which is h, by adjacent rather, which is what, AQ. Now, and tan 45 is 1, which will give us h over what, AQ. And our AQ here, when we make it this other formula, we have that AQ will now give us what, h. So here also it is what, h. Now that I've gotten this side and this side, still using the Pythagoras theorem, let us find the hypotenuse. Now the hypotenuse, which is what, PA, will give us square, will give us PQ square plus AQ square, and this will give us PA square. Now PQ here, we have h square plus AQ, which is TH, and PQ square will give us what, 2h square. Right, now let us find the square root of both sides. So here we have that PA will give us the square root of 2h raised to the power 2, which implies also that PA will give us what, h, the square root of what, 2. So here you have h equals to the square root of what. Okay, alright, to this effect now we've gotten all the whole sizes. Okay, alright, so let me probably redraw the diagram with the sizes mentioned so that it will be very clear and visible to understand. Okay, now here we have it, a clear diagram of the question. Alright, now for us to solve now, since we are told to find a relationship or to prove a relationship between D and H, and here we have D, we have H, we have H, we have H. Alright, now but considering this set of triangles here, this is P and this is Q, this triangle here, and a trapezium here. Now this and this and this, in solving it, might be complicated. Now let us see this triangle. Now take note that this is B, so AB, ABA. Now let us resolve this using the sine rule. Okay, now using the sine rule, here we have this is 15, well, that will be D here. Okay, and here is 150 as indicated and as solved in the previous video. Okay, before now. So here we have, using sine rule or sine the formula, you have this P, small p. Okay, here you have D over sine 15, then equals H, the square root of 2 sine 150. Okay, and the sine rule is giving us A over sine A equals B over sine B equals C over what, sine C. Alright, so following this, we have that A, we can make, let us make this one our A. Now the angle, which is this, we have that. Then B, which is H root 2, and the angle opposite it is sine 150. Now resolving this, according to the trigonometric function, sine 150 here is the same thing as sine 30, since they are in the first, second quadrant. Here you have it, this is 150, so it's within here. So, and sine here also is positive, so which means 180 minus 150, which will give us 30 degree. So you can see this is also 30 degree, and see this is D over sine 15, then equals h, the root of square root of 2 over sine 30 degree. All right, now simplifying this, now we get, so we get that d over sine 15 then equals to h, the square root of 2 over 1 over 2, and this will give us sine 15. Now for us to resolve sine 15, now let's come over here. Sine 15 could also be 45 minus 30. Now I recall that from this trigonometry identity, plus or minus b here, now this will give us sine a cos b, now plus or minus cos a sine b. All right, now since we are involved here with minus, we can now say this is sine 45 minus 30 then equals, now wherever we see a, we replace it by 45, wherever we see b, we replace it by 30. So here you have sine 30, now cos, oh sorry, sine 45, now cos 30, then minus, since this sign and this sign they correspond, now cos a, which is 45, that will be cos 45, then times sine 30. Okay, all right, take note, all these ones are in degree. Now we know that sine 45 equals 1 over root 2, now times, now cos 30 here is root 3 over 2, then minus here cos 45 will give us 1 over root 2, and sine 30 here will give us 1 over 2. All right, now resolving this, we have the square root of 3, that is 1 times root square root of 3 will give us 3, 2 as the square root of 2 times 2 here will give us what, 2 root 2, then minus 1 over 2 root 2. All right, I believe you are following. Now since we have the common denominator here, according, so here we have the root 3 minus 1 over 2 root 2. All right, so it means sine 15 here is the whole of this expression. Now this will also give us d over sine 15, then equals to, here we now have h root 2, I mean the square root of 2. Now this implies divided by 1 over what, 2. Changing this sign here, you have h root 2 times what, 2, which will give us what, 2h root 2. So as such here we have 2h root 2. Now let's cross multiply. So here we have that d equals 2h root 2, then sine 15 degree. All right, so now take note that sine 15 here is this. So here you have that d then equals to 2h, the root of 2 into root 3 minus 1 over 2 root 2. Now, but we'll probably need to rationalize here. Now by rationalizing here, which implies the root 3 minus 1 over root 2, I mean 2 root 2. Now we have to rationalize, and by rationalizing it means we have to multiply the numerator and the denominator by the denominator, which we have 2 root 2 over 2 root 2, and this will give us 2 root 6 minus 2 root 2, then over 4 times 2. Okay, all right, and after which here we have that d equals to 2h root 2 then into 2 root 6 minus 2 root 2 over 8. Okay, now you can see that the common factor here is 2. So this here will give us that our d here will give us 2h root 2. Now this is a common factor which will give us 2 into root 6 minus root 2 then all over what? 8. So 2 here 1, 2 here 4, and 2 here 1, 2 here 2. So here you have d then equals to h root 2 now into root 6 minus root 2 then over 2. Now you can see that root 2 is also common here. So here you have d equals to h root 2 times root 2 now into root 3 minus 1 then all over what? 2. Now root 2 times root 2 give us what? 2. So here you have that d equals to 2h now into root 3 minus 1 all over what? 2. 2 cancel 2. So at the end of the day you have that d equals to what? H into what? Root 3 minus 1. Final answer. Alright, now that we've proven it, really if you love what I've just done, kindly subscribe to my YouTube channel and ensure you click on the notification button to be notified of all my videos. Thank you and God bless you.